Okay, folks, let's do a couple of examples of metric conversions here. So we got some mass. That's something we can see with our weights here. So we're starting off with 2.5 kilograms. Well, here's a kilogram right here. And so if we start moving it to grams, it becomes very obvious to us that we're going to be having a huge number because just one of these packs 1,000 of these. So if I have more than 2 of these, that's saying I have more than 2,000 of these. We can actually see that sort of scale. This is, once again, is 3 placeholders of a value larger than the gram value. So we are going to move we're multiplying by 1,000 because kilo means times 1,000. If we have 2.45 kilograms, that's saying I have 2,450 grams. We've moved the decimal place 3 places to the right. That's what's happened. If we wanted to put this in notation, we would say this is 2.45 times 10 to the 3rd power grams. I won't do this for everything, but just to show you that is the equivalent here. Conversely, if we're going from grams to milligrams, milligrams means thousands of grams, so it's very, very small. We're moving 3 more places to the right. 1, 2, 3, we have 2,450,000 milligrams right here. And then micrograms. Notice how I'm drawing the milli symbol and the micro symbol differently. That's micro means millionths of a base value. That's millionths of a gram. But remember, we're going from all the way back from kilograms. So we've actually moved the decimal 3 places, 6 places, and now we're about to move 9 places. 2, 4, 5, 0, 3 places, and then 3 more places right here. So we have 2,450,000,000 micrograms in what is about 2.5 of these. So a microgram obviously is a very tiny value, smaller than any scale that we have in this room. The best scale we've got, the best balance, goes to 1/10,000th of a gram. So that just to give you a sense of scale there. Here we have micrograms. So we have a very small value, and we're converting it to bigger values. So as you can guess, the decimal is going to be moving successively in orders of 3 to the left. So we wind up having 836. We're going to move this decimal 3 places, and we have to have placeholders for this. So those become zeros. If we want to put this in notation, that's 8.36 times 10 to the -4th, just for comparison here. And we're going from millis to base value. Well, that means we have to go 3 more placeholders. 1, 2, 3. And so, of course, it's a very, very, very tiny value we're getting to at this point. So, as you can guess, go to kilograms, we have, once again, 1, 2, 3 more places to go towards the left. So let's go ahead and do that, and I'm going to have to kind of adjust here to fit everything. 8, 3, 6. I'll just kilograms here, 8, 3, 6, and let me clean up this sloppy 6 here. 1, 2, 3, that converted it to milligrams. 1, 2, 3, that converted it to grams. And then 1, 2, 3, that converted it to kilograms. So you can see this is an unwieldy number, and this is why we're going to be getting into scientific notation as a way of making shorthand versions of these really long, stringy, unwieldy numbers. we will learn that we can basically replace this crazy number with 3, 6, 9, 10 by using exponential values to replace these kinds of numbers. This is really the subject for a future video, but we will learn how to take these awkward numbers and rewrite them in a way that's a little bit simpler. But in closing here, once again, for the most part, except for Cinti's, we're moving in groups of 3. 3 places, 3 places, 3 places, 3 places, all the way from micro to milli. That's the scope of measurement that we use in a practical sense in this particular